Okay, so now the idea here is to know how to derive entanglement witnesses from this dual. In fact, like if you remember in a last video, we said that the set of separable states uh, was like this. After we had like, for example, the set of untangled state being these points, and that if we wanted like to check about this, like to know if a state was separable or untangled, we just have to check that the trace of row AB of W is equal to 0. So using the Lie with trace A row AB and row AB W here. Here A is Hermitian, so it means it can also be an observable, it can behave like W, and so we can use this fact. So basically, we have these constraints. We know also like so that for all separable states, the median value for the operator is positive or null. So it means like so. Basically, we have let's say we would instead of calling it row AB, we'll take a state C that represents it. Have like the trace of C W that will be superior to 0 if separable. And if a trace of WC is strictly inferior to 0, then it is untangled. So that's the first thing we need to know about, that you need to remember. The second thing you need to do about to answer this question on derive entanglement witness is that we want to know about the primal, if it is possible or not. And we know that the primal is always inferior to the dual by weak duality. No matter the point if it is realizable by the dual, it will be always always superior to the value of any point realizable by the primal. So that's it. That means like our primal here was just about t, so it means even the maximum of t, which represents the primal, will be inferior to d, and d, as we saw, is just this trace of a or ab plus lambda, but we can call it like cab to say we take a particular state, but you can write it as you want in reality. So now if we apply this this thinking to the exercise, like the first thing we need to do is like so that the two stuff of knowledge you need to have about. But now to answer the question, like the first step we need to do is just to say, okay, we take like a b c lambda that respect the constraint of the dual. Like, yeah. And so after, what you want to do with it is like you measure A, because A is immersion, it can be like it can be measurable, we can measure it, and we calculate its value, its median, its average value in the state CAB, and we add lambda. So we measure A, just write determination. So we measure A, um, and after we check its average value with the trace, and add lambda. So we literally have this now. We just forget on this, but we show like physically how can we can do it. And so for this, if you observe this result is negative, and more especially like strictly negative, because the primal can be it's weakly dual, so you have this. But if it is zero, we are not sure if it is entangled or not. Like so, it should be like strictly inferior to zero to be entangled. So if you see that this is strictly negative, so basically the trace for A plus lambda is strictly negative, then you also know that Tmax is strictly negative 2, because we write here this, or we saw, well, yeah, it means Tmax is strictly negative. Because we saw that Tmax is inferior or equal to the trace of, say, the A plus lambda by weak duality. But we know that if Tmax is negative, it just mathematical proof that the states CAB does not is not inside by the set of states defined by the primal. Indeed, like, because if Tmax is strictly inferior to 0, like if you check the condition of the primal here, it means like we know that rho should be semi-positive definite because it's a density matrix. So yeah, rho should be semi-positive definite, and so because rho is bigger than Ti is positive definite, and so if T is negative, it cannot work. So T must be positive. T, like, it's a condition about positivity, and so because there is this condition of positivity about T, it means like primal condition, and so it's this condition implies T should be superior to 0, So there is a contradiction here that we find that Tmax is strictly inferior to 0. And so it cannot be inside the set of the states defined by the primal. So yeah, it means like array B does not goes into the set of states defined by the primal and does not is into the set of DPS, and so there is no possible symmetric extension. Not possible symmetric extension because, like I said, the definition of DPS, and so if there is no possible symmetric extensions, it just means the state is entangled. So yeah, basically we just derived entanglement witnesses from this dual.